Welcome to this video about the derivative of a function. Remember from the lecture about the equation of a straight line that this constant term represents where the line intercepts the y-axis when x is equal to 0, whereas the coefficient in front of x represents how much y increases if x increases by 1 unit. For example, we see that y increases from 3 to 5 when x increases from 1 to 2. We therefore know that the line has a slope of 2 because y increases by 2 when x increases by 1. Note that we will get the same slope if x increases from 2 to 3, because y then increases from 5 to 7. The derivative of the function of the line is the slope of the line in this example. Note that the slope of the line is also called the gradient of the line. The derivative of a function can be expressed as y prime, whereas the derivative of y with respect to x. This notation is called dy dx and tells us how much y changes when x is changing. Since we know that y increases by 2 when x increases by 1, we know that dy dx is equal to 2. Instead of having the variable y on the left-hand side, this notation is sometimes used, which is called f of x. The derivative of a function is therefore sometimes expressed like this. If you drive a car along this line, from left to right, we go uphill. When we go uphill, we know that the slope is positive, which means that the derivative is also positive. So, what is the derivative of the following function? Since the car goes uphill, we know that the derivative is positive. And since y increases by 1, when x increases by 1, we know that the derivative of this function is equal to 1. In other words, if x increases by 1 unit, y increases by 1 unit. So, what is the derivative of the following function? Since we can see that the slope is 0.5, we know that the derivative is equal to 0.5. Because y increases by 0.5 when x increases by 1. What is the derivative of the following function? Since the slope is equal to 0, we know that the derivative is 0. Since 0 times x is simply 0, we can eliminate this term, so that y is equal to 4. This means that we have a horizontal line where y is always equal to 4 even though x is changing. If we drive a car along this line, we neither go uphill nor downhill, which means that the derivative is equal to 0. So, what is the derivative of the following function? Since the slope is negative 0.5, we know that the derivative is negative 0.5. When the derivative is negative, the car goes downhill. A derivative of negative 0.5 means that y decreases by 0.5 units when x increases by 1 unit. Finally, the derivative of the following function is equal to negative 1.5 because y decreases by 1.5 when x increases by 1. To summarize, if we drive uphill along the line, the function will have a positive derivative. And if we drive along a horizontal line, the derivative is equal to 0. And if the car goes downhill, we know that the derivative of the function of the corresponding line is negative. So, what is the derivative of the following function? This type of function is a bit more complicated, because the derivative depends on the value of x. If x is less than 2, the derivative is negative. If x is equal to 2, the derivative is 0. And if x is greater than 2, the derivative is positive. We therefore need to find the derivative of this function. For this type of equation, we can use the power rule, which says that the derivative of x to the power n is n times x to the power n minus 1. We can think of this as we move n down here and reduce the exponent by 1. Let's apply the power rule on x to the power 3. We therefore move the 3 down here and reduce the exponent by 1, so that we have 3x to the power 2. Likewise, the derivative of 2x to the power 2 can be found by moving the 2 down here and subtract 1 from the exponent, which results in 4x to the power 1, or simply just 4x. If you use the power rule to calculate the derivative of the following function, we can think like we have x to the power 1, because that does not affect the equation. We now move the 1 down here and reduce the exponent by 1. We can then simplify. Note that something to the power 0 is equal to 1. The derivative of this function is therefore equal to 3, which means that the slope of this line is equal to 3. Note that the derivative of a function including only a constant term is 0, because the slope of the corresponding line is 0. Let's use the power rule to see if we can find the derivative of the following function. We move the 2 down here and reduce the exponent by 1, and simplify. We then move the exponent down here and reduce the exponent by 1, and simplify. Remember that the derivative of a constant is always 0, which means that we can ignore this term when we calculate the derivative. We now have the derivative of the function. For example, if you like to know what the derivative is when x is equal to 1, we set x to 1 and do the math. We see that the derivative is equal to negative 2 when x is equal to 1. We can see this as we place a line that just touches the curve when x is equal to 1. The slope of this line is equal to negative 2. This type of line is called a tangent line. The derivative of the function when x is equal to 2 is 0, because the corresponding tangent line will have a slope of 0. The derivative when x is equal to 4 is equal to 4. Now, let's find the derivative of this function. We move the exponents down here and subtract 1 from the exponents, and simplify. If you like to know the derivative of this function when x is equal to 1, we set x to 1 and do the math. We see that the derivative of this function when x is equal to 1 is 4. The derivative of the function when x is equal to 2 is 0. And the derivative of the function when x is equal to 3 is negative 4. This was the end of this lecture about derivatives. Thanks for watching.